and thank you for having me. I'm going to talk about going from data to simulation, open source hydrological model building and modeling using HydroMT and wflow. And I'll start with just a very quick introduction that we need robust tools to guide our decisions to achieve water security in a rapidly changing world. And this is just a very short introduction to present wflow, which is the Deltares open source hydrological modeling software. It is used for catchment scale rainfall runoff modeling. It is fully distributed, so it's grid-based. And of course, being part of this session, it is open source and free. The source code is written in Julia, but there are also pre-compiled versions available for the registered users, and there is online documentation available. And without going into too much detail, the hydrological model contains all the relevant vertical and lateral processes, but maybe more important to mention, it also has lakes and reservoir modules, a water demand module, and an optional, everything is optional of course, but also a sediment module. This model can be set up for small basins, but also for very large basins. And so it is then usable for really regional applications where you build a model that is locally relevant. It can be applied in data-rich, but also in data-poor environments. At Deltares, we often use it in a wider project, for example, for the calculation of reservoir inflow, for input for water quality modeling, or for groundwater recharge calculation, for sediment inflow into reservoirs or lakes, or as an input for flood modeling. And well, these type of models obviously need data, and there's also good data becoming more widely available. It becomes also more available at higher temporal and spatial resolution. And as the data improves, we also want to improve our models. But typically, the process of building models takes a lot of time. We need to discover the data sets, we need to access the data, to pre-process the data, to make the data available in the correct format, and then we have maybe a model that is ready for analysis, but maybe then we lack time to really analyze the model. And so I think what is also really unique about the wflow model is that it comes with a Python package for model building, which is called HydroMT. And HydroMT enables, through a data catalog and a model configuration file, to very rapidly, in an automated way, build a model that is ready for analysis, making it reproducible, automated, flexible, scalable, and fast. So giving you a little bit more details about HydroMT, which is short for Hydro Model Tools. So it's an open source Python package, and it's built up in such a way that it has a core and that it has several plugins. And one of these plugins is, for example, for wflow, so for the hydrological modeling. But we also have a plugin for Sphinx, which is a hydrodynamic model, also for Fiat, which is a flood impact model, for the water quality, for coastal hydrodynamic, and we plan to expand these plugins for other models. And so you can really build up a chain of models to go quickly to impact as well. And in that way, HydroMT is at the interface between the data, the users, and the water system models. And it includes actually a set of GIS, hydrological, statistical, and plotting methods needed to rapidly build and analyze models. And it is available through a command line interface. And with HydroMT, we move away from the more classical approach where we spend a lot of data, like collecting more data, trying to pre-process that data, building a model, also then maybe not using all the data that we had collected anyway. And then with the HydroMT, we we shift towards this new approach where we can very quickly build an initial model based on available global data sets. Then we already have results, which makes it easier to discuss with clients which improvements are required, which data is needed to make these improvements, and then to maybe collect local data that we can also include in the data catalog and then easily access and process. And then there is much more time to really analyze your model, improve the model with the new data. And we are doing a lot of projects which use these tools. And one of the projects that I've been involved in was to develop a climate rationale for Bhutan. So we set up a wflow model for Bhutan, first using global data. When it was available, we updated our model with new sources of data, and we evaluated the impact of climate change on the water resources. We focused on extreme events, but also on the drying up of mountain springs, and we evaluated adaptation options. And because we do these types of study more often, we are also in the process of developing a climate stress testing toolbox. It's not yet open source, but soon to be open source. And it provides standardized climate stress testing that can be applied in any basin, and which use these tools, HydroMT and wflow. And yeah, very quickly, but what these tools do is that they generate synthetic climate trajectories, they assess the hydrological response, and they identify robustness and conditions leading to vulnerability. Well, and then as a summary and call to action, I repeat the sentence that I said at the beginning, that we need robust tools to guide our decisions to achieve water security in a rapidly changing world. And I would like to invite you to co-create with us in the software development of these tools, for which I've provided, I don't know if the links are behind here, but I don't know if the presentations will be shared or, yeah. Thank you.